Professional sports leagues generate an enormous amount of scheduling data. A single Major League Baseball regular season contains 1,833 individual games, each with specific locations, start times, and opponent matchups. For decades, finding a specific event in a dataset that large meant forcing users through a rigid interface. You have to click through cascading drop-down menus, toggle date filters, and wrestle with strict search box parameters just to find out when a specific team plays at home. To bypass that friction, we built a natural language interface. Instead of forcing the user to filter the data manually, they can just ask a question, and the system instantly organizes the complex schedule data in the background. A fan can simply type, "Show me the next 5 Yankees games," and the interface instantly returns exactly those specific game cards, skipping the search menus entirely. The moment the user interacts with that game card, a background process fires off an email notification. This securely delivers a standard IETF calendar invite directly to their personal inbox. This entire workflow runs on 2 core pieces of infrastructure: the calendar invite server, built on the AWS serverless stack, and Anthropic's Claude Haiku model, interpreting the user's requests. Running natural language queries against massive datasets is highly efficient. This specific implementation cost less than a single cent for an entire session of 10 to 15 questions. By combining advanced prompt caching with serverless messaging, developers can bypass heavy front ends. Standard email inboxes become highly efficient, headless engines for creating, reading, updating, and deleting records. The user's experience starts in the browser, with a front-end application built on Vue 3 and styled with Tailwind CSS. But connecting this front end directly to the AI model presents a serious security flaw. Exposing LLM API keys within a client-side browser application gives anyone inspecting the code full access to those credentials. To secure the connection, we insert a Firebase Cloud function. This acts as an intermediary proxy layer, taking the user's input from the Vue client and securely routing it to the Claude Haiku API without ever exposing the key to the browser. Managing an 1,833 game schedule requires a specific architectural approach known as prompt caching. We compress the entire schedule data into a single text block. That full schedule is loaded into the AI's context window exactly once, on the very first message of the session. Every follow-up question the user asks pings the model without needing to reload the entire dataset. Avoiding those redundant data loads is what makes this economically viable at scale. You only pay for the heavy initial schedule upload once per session, dropping the cost of subsequent queries to a fraction of a cent. The model itself operates under strict instructions. The system prompt explicitly forbids unstructured conversation. The LLM must only output a highly structured JSON contract. That contract contains exactly 3 things: the requested list of games, any brief conversational text, and the specific action type. The Vue frontend reads this JSON response and directly renders the UI components, like the individual game cards, completely eliminating the need to guess or parse raw text strings. Prompt caching paired with rigid JSON constraints strips away the conversational unpredictability of an LLM. It forces the model to act as a deterministic database engine. Before the AI can query those 1,833 schedule events, the data actually has to be loaded into the system. This relies on the Calendar Invite Server, or CIS, which uses a headless calendar client architecture. Traditional event management usually demands building and maintaining a complex, custom graphical user interface. This serverless architecture entirely eliminates that outdated requirement. Instead, the organizer simply uploads standard fixture download iCall files directly into an everyday Google or Microsoft Calendar client. The trigger mechanism is an email. The organizer sends the created calendar events from their client to a dedicated processing inbox at create@calendarsnack.com, which serves as the direct entry point to the AWS API. Behind that inbox sits an extract, transform, and load function deployed on AWS. This ETL pipeline intercepts the incoming payload and processes the calendar data. It parses the raw data via the AWS Simple Email Service and permanently assigns a unique alphanumeric ID, or UID, to every single event before storing it in the database. This creates a built-in update loop. If an organizer needs to change a game time, they just modify the event in their Google Calendar and hit save. Those standard edit and save commands push the updates back to the same endpoint. The ETL pipeline reads the incoming update, matches the assigned UID, and seamlessly overwrites the existing database record. This routing strategy takes everyday consumer calendar applications and turns them into highly secure, headless administrative tools for managing enterprise databases. With the data stored and the AI processing requests, we can trace exactly what happens when a user clicks a button to request a calendar invite. The JSON contract generated by Claude automatically fires a request to the calendar invite server's Send API. The system uses the AWS SES Raw API to pull the current database record using its UID, dynamically assemble it into a fully formatted IETF calendar invite, and send it directly to the user's email. Because this delivery mechanism relies entirely on the serverless AWS stack, it functions instantly, completely bypassing the need for heavy, dedicated email server infrastructure. Every invite sent complies with standard IETF calendar client collection guidelines, meaning it automatically requests an RSVP receipt from the recipient. Every invite sent complies with standard IETF calendar client collection guidelines, meaning it automatically requests an RSVP receipt from the recipient. When a user clicks yes, no, or maybe in their local calendar application, that action automatically generates a calendar receipt that routes right back to the server. These returning receipts arrive at an API gateway for storage and analysis. Each receipt is permanently tagged with the original event's UID, allowing for precise tracking across thousands of users. This closed-loop tracking powers the Event Snapshot tool. Organizers can pull highly accurate analytics on individual events simply by clicking an email report button. These reports capture precise data points, including the user's email address, their exact RSVP status, origin, and the product ID of the specific calendar client they used to respond. For broader scaling, the system utilizes a multi-tenant architecture. All invite and RSVP data for multiple organizers is cleanly aggregated under a single AWS SES domain for comprehensive reporting. By leveraging standard IETF RSVP protocols, developers can build a zero-friction analytics platform. It tracks user intent with complete accuracy without forcing the user to download a separate application. The full data lifecycle moves from headless data entry in Google Calendar through AWS ETL processing into AI querying via prompt caching, and finally out through SES delivery. In this initial Phase 1 build, the architectural boundaries are strict. The system explicitly excludes highly volatile information like live scores, current standings, and broadcast data. Feeding rapidly changing real-time data into the LLM context is inefficient. It leads directly to excessive token consumption and significantly increases the risk of AI hallucinations. In Phase 2, the integration strategy shifts. Live sports data will be surfaced strictly within the View UI using standard REST APIs, keeping the AI focused solely on the schedule. This approach proves the value of decoupling raw database management from the user interface. By isolating the AI middle tier from the headless backend, developers gain maximum flexibility to iterate on the front-end design. The calendar invite server demonstrates that legacy IETF protocols and everyday email clients are highly capable tools. When connected through precise serverless routing, they can effectively power the next generation of AI-driven applications.